Today I want to talk about the accessing the databases with NFX, working with data stored in the databases. Now, let me signify one thing here before I start. NFX is a practical framework. It is not a puristical framework. It does not stick to a particular puristical paradigm like, for example, link to SQL or Hibernate or something like this. It uses whatever is the most efficient and the most easy to use for building practical, let me underscore it, underline it, practical applications. Okay, so therefore you're going to hear a lot of things that most of you will probably say, no, it cannot be like this, because there are many things here that are different, purposely different from what most of you guys are used to. Okay, so let's first make a few statements here. NFX never used any object relational mappings in its pure form like you were used to, using like Hibernate or link to SQL. NFX never supported link to SQL, and we have no intentions to support it. There is no need to support the concept of integrating the language in your database queries in the language. Okay, there is a lot of thinking that went behind this design. NFX is really a hybrid solution. It is not an ORM solution. It is not a what would you call it? A non-relational solution or purely relational solution. It's a hybrid of all of those technologies that would allow us to create the actual application. So let me first look at some code here for the NFX. In the data access namespace under CRUD, we have the all of the backbones, and the first and foremost thing here is the row. Okay, so the row represents an abstraction of the record or a document in the database or file or whatever. Now, an interesting part of it is that because this is just like a class, this thing here is used not only for database programming, but it is used for many things like for forms, creation of form models for building UI, for example, as you will see in a second. Okay. So a row basically is an object that has a schema, okay? And there are two types of rows. The row is an abstract class, and there are two types of rows: dynamic rows and typed rows. Dynamic rows are rows where you can set the schema at runtime, okay? Just like your dynamic languages do. For the typed rows, you do something else. A typed row is a kind of row, but you set the schema by declaring properties of that row, if that makes sense to you. So the schema is self-obvious. It becomes obvious when you implement the class that derives of typed row, and then the schema gets populated automatically. Now, what is the schema? A schema is a list, basically, or enumerable of field definitions, okay? And it is JSON writable object, and I think I explained in a different video what JSON writable means, but basically it tells me that it does the custom write serialization as a JSON format. The field def is a vector of the following fields. It has a name, order, type, non-nullable type. This is important. Okay, it has a list of attributes. Then it has some cache member info to access the that field during the runtime. And some other things here. This is a pretty big library here, but I mean, it depends on what you compare it to. If you compare it to Hibernate or NHibernate, it is like 1,000 times smaller library that allows you to do very many things that Hibernate can't even dream about. Okay, but as far as showing all of the code in one video, that's probably a little bit of a stretch. But other than that, so basically the schema is just a named bag of field definitions. Okay, so here, dynamic rows are shaped, so to speak, in memory from schema, whereas type rows define schema by just deriving from a type row. Okay, and it does all of thread safe, static, etc., caching, not to calculate all of that stuff every time. Okay, so if we look at the attributes, this is where it gets interesting. There is something called a targeted attribute where you can specify the target. The target is the name of your database platform, like Oracle 1 or Oracle 2 or Microsoft SQL Server, and you can call your target the name of your platform. Let's say your software is called XYZ. So you can call your target Oracle _ XYZ. So what is the target? The target is just the name of your technology. And then basically what happens when you decorate your rows and stuff with the attributes, you can put targets in there. So you can put multiple attributes for every field. Let's say that in your older system this field was called SD, like start date. But in the Oracle database it is called start _ date. So you can put two field attributes on the same property and it will resolve dynamically what name to use at runtime. Okay, that's what it's for. So that's the table attribute tells your statement builder the name of the table. It's a targeted attribute. So your table may be called orders in your Microsoft SQL Server, but it can be called TBL _ order in your Oracle. Then you would put the target name Oracle, and then it would generate that name, take that name. Then the field attribute, there are pretty flexible things here that allow you to specify those values, the kind of data that the field stores, required visible, value list is like a pick list, default, min, max, min length, max length, character case, backend name, that's actually the name of the field in your backend, like I said, Oracle or SQL Server, and you can attach any kind of structured metadata as a form of config file to your field. And this is how we generate all of the UI. So this is not only a database model, but it can also be a view model. It doesn't have to be, but you can do it if your system is simple. You can put it all in one place. So the field attribute, that's what it's used for. Okay. Now, when you create a row, you either create a typed row or you create a dynamic row. The dynamic row, like I said, you can shape those guys. Let's look at some unit tests here. Okay, so this is an integration test for MySQL. Let's look at the test objects here. So here is my patient record. Okay, it's a typed row, okay, and it has those fields here with those metadata, and I don't use targeting here because I only target one database in this unit test. But I could have said field target name Oracle is marker, field target name SQL Server is merc, or something like that. So on a different platform, the field will compile to a different name. That is, in a different SQL statement, the field will be called. In a different backend name, the field will be called a different name. So what this allows me to do, if you think about it, it is very similar to ORM, but it's a very different system at the same time. What this allows me to fetch those instances of these records from the database, okay, and it allows me to work either with the type data like this, or if the row is dynamic, I can access it with a square brackets and pass the field names as a string. Okay, so here's a good example. The name of the field in the database is fname, not first _ name. You see what I'm saying? That's what it does. Okay, and again, if I do comma here, I will get a lot of properties here that I can specify. Okay, so I can pretty elaborate on this. So with the dynamic validation, this guy does the validation. Whatever it can infer from metadata, it would do that for you automatically. It will check the required columns, it will check the formats for phone numbers and dates and everything. But there are some things that the computer cannot do automatically. For example, let's say you have a start date and end date. If end date is set, it has to be past start date. You can do that very simply by just saying override and then do validate, I think it's called, or validate here. And then what's going to happen here, you're going to get the target name. That's the name of the target that you're validating against. And again, this name comes from, if you work with Oracle Data Store, the target name can be called myxyz_aura. Okay, or myxyz SQL Server, Microsoft or something. So you can do conditional validation here. You can write if statements if you want to, but you can do crazy stuff here, but most of the time it's not necessary to override this member here. Okay, the store flag tells it whether this column is computable or this field is computable. Should it be loaded? Should it be stored? Should it be transparent? Let's look at this. Load and store, only store, and none. Okay. So I think pretty self-explanatory. Okay. So then what you can do now, you can inherit those rows. So here I have a super patient, okay, and it has a Superman flag, true or false. And by the way, all of the primitives, they can be nullable. If you just attach this, they become nullable. They can store null in the database. Now again, I don't want you to think in terms of relational database system. Let's try to make our perspective broader and try to encompass things like NoSQL, or rather not only SQL, not NoSQL, but not only SQL systems like Mongo or other like Couch or whatever, HBase and all of those other guys. And let's consider different data sources. For example, let's consider calling a weather.com web service to get my weather for my zip code. It doesn't have to be a relational database system. So therefore, in NFX, the concept of working with database is proclaimed here via this interface, data store. Every application in NFX has a data store. Okay. Even if you don't need one, you have it. It's going to be a NOP, no operation data store that does nothing. But you have a concept in the application container. So what does this mean? What this means is this. Wherever I am in the code, I can do app.data store, and it will give me the pointer to my data store for my application. Okay, it's like a global dependency injection container that NFX provides for you. Okay, so that explains this. Now there are a lot of things here. The most important thing to understand here is that there are rows, they are dynamic, and they are typed. Another important thing to understand is the amorphous data. Okay, the word amorphous means no form. Okay, no something without the form. What that implies, even if you have some schema in the database, you can say that your row supports amorphous data. This is like an out of schema data that you can process between your schema upgrades. This is an extremely important feature when you have to deal with schemaless designs like MongoDB, for example, where you have, let's say you have 10 billion rows, and you have added a new column to your, or new field to your typed row, and the database doesn't have this information, so it is going to be null. But let's say that you used to have a field and now you got rid of it because you moved that information to a different table. you need to convert existing data. This is what amorphous data does for you. First of all, it has a flag. Even if your row supports amorphous data, you can enable it or disable it. Okay, you can say amorphous data processing is disabled on a row-to-row instance. This is very important and very flexible. And then the amorphous data is basically a dictionary of the name of the column and the value of the column. Okay, or I shouldn't use the word column. There are no columns, field. Okay, because it's not necessarily a tabular data that we're talking about. This is a very important thing to keep in mind. We're not talking about tabular data, so pardon me, I shouldn't use the word column. There are no columns here, only fields. Okay. And before save is a hook that is going to be called before you save your stuff. This is where you can convert your new field into older field into new field, and after load is a complementary hook that is called after you load your data. Whatever columns couldn't be matched into your current schema. Let's say you used to have a field middle name, okay, and now you don't support this field anymore. So where is the field from MongoDB called middle name, or MN, let's say it's called? Where is it going to be fetched into? If you have an amorphous data enabled on your provider, it will be matched into this collection under the name MN, and it will be the middle name. But now you don't have a field in your typed object called middle name, so now you can take that and merge it into your first name using comma, or last name using comma, or whatever you want to do. So I guess that explains what amorphous data is, okay? So now if we come to this amorphous type row, is a kind of type row of typed row that allows you to implement this amorphous data interface, and has this dictionary which is lazily created, ordinal ignore case, for comparison of the names, and it just merges that data in there if it's there. If not, then it's blank, it's empty. So that explains what amorphous data is. And then now let's look at those interfaces here. First of all, let's look at the CRUD operation. A CRUD operation, CRUD operations is a contract that allows you to get a schema for your query. Now you see that? It gives you the schema object. So now you can issue a query to your provider and get the schema back, and you can build a dynamic, for example, row in your memory. Let's say that your provider is 100% dynamic and you don't even know what kind of schema is going to come from there. You can do it like this. The load command is going to take a series of queries and resolve them into Rosettes. And we're going to talk about Rosettes in a second here. And then load one Rosette is the similar but is more optimized version of this. Load one row is even more optimized version of this if you need to load just one row. You usually load one row, like if you do a login or something like this, you know, like select this user, either get nothing or one row. You know what I'm saying, like fetch scalar value. Then it has insert, upsert, update, and delete. And notice those guys, they take rows, whereas save takes Rosettes. So if you're familiar with like Microsoft Dataset and Microsoft Data Table, this is a similar concept, only this is more flexible, and there's like 3,000 times less code than Microsoft has. Okay, so if we look at the Rosette base, it's a list of rows, okay, with particular, it's a comparer of rows, and then the Rosette provides base for Rosette implementation. There are two types of Rosettes. There are there are Rosettes that are called tables. A table has a primary key, and it allows you to maintain clustered index in memory, and this is very important. Actually, I use this code in the high frequency trading system that has to like merge 25,000 rows a second coming from the market theater, okay, from the TCP socket that is fed from Erlang process. And what I do here, I use the table and it does a binary search and it maintains, so you see the insert and those operations here are, I think it's here in protected. Search for a row, it does a classic binary search right within the clustered index. As I mentioned before, rows, they support key fields, of course, and you can know what a key field is, okay? Now, and so one type is table, and another type of the row is, if we do find all references, you get a table and you would get a what is it called? The Rosette. The Rosette is a similar concept to the table, but it doesn't have a primary key, but it supports sorting and indexes and all of that, like sort definition. You can just put, you know, what this does, actually, it creates like a clone cursor on your client. So what this is used for, let's say you need to show a grid to your client, and you have the data in memory and you need to refilter or resort the grid. This is what Rosette does, okay? So a table is a different kind of Rosette that has a key field and it is going to give you key violation. The Rosette is not going to give you key violations. It's just going to sort everything, and even if it has duplicates, it allows to have duplicates, okay? So that is, if you want to process data in memory, you can do that using those classes, okay? But what those classes are mostly used for, they're used for working with the database and retrieving that information from the database. And again, let me signify it. Do not think about relational databases only. Let's think about databases, any kind of data that counts into your application. The CRUD data store is a form of the CRUD operations. It has support for transactions, okay, or it doesn't. It supports transactions true or false. The store type is just a category, if that's relational, document, key value, hybrid. It's just a high-level classifier, and it provides something called query resolver. The query resolver is an entity that resolves your query request into a query handler that handles your query. Now, what are queries? Because we cannot write queries based on SQL. This is not a SQL system, not an SQL only system. We have to write our queries as a command object, so to speak. It's just a list of parameters that has a name, okay? It has a name, it has some extra data and some keys and some you know, types. You can give it a hint what kind of type you want to fetch, or it will fetch it automatically. So whoever executes the query, the provider does. The provider for a particular backend turns your query object into actual result set. And that result set doesn't have to be a series of rows. It can be like a string or something like this, okay? So other than that, everything else here is self-explanatory. The CRUD transaction is basically an interface to transactions. It doesn't have any implementation, but it opens a transaction handle. And that handle, if it's not implemented by your backend, you're going to get the same interface that you get from your data store, and that transaction is going to be fake. But you have to understand it. You can query your data store, your particular data store, and see if it supports transactions or not. Okay? So the concept here is to write a 100% transparent code that is not connected to relational database technologies in any way, shape, or form, but at the same time, it can use all of the features of relational database technologies like Oracle, MySQL, IBM DB2, MySQL, MS SQL, all of those guys, we can use all of it, okay? Now, let's look at the, so I think we looked at those interfaces here. Let's look at the test object here. So this is my unit test. I have some test objects here now, and then we have in the test logic, we can see how we work with it. So here, let's say I execute a query. I declare a query instance here, and I give it a name. So the query is the service. Think about it as a URL. Just think about it for a second. So your request to the database now is like the address of or the address and the name of what you want. So CRUD patient list. This is the naming convention I use here. And you can definitely wrap those things because the data store is just a class. You can wrap them in your particular application in the safe interfaces and safe types. So the user of your data store will never see this. But this is the unit test. That's why it's all written here. The lower level code is right here. So I pass here a store, a data store, CRUD data store right here. And this code is going to execute against any database I want, as long as I have a provider for that database. Okay, so I have this query here. I give it a parameter, okay? And this is a little bit of a half-assed job I did in the unit test because I use, this is actually SQL, what do you call it, wildcard character, and this is not really portable code because what happens if I run this query against the HBase or something and it has a different concept, so I should have rephrased it, but because I mostly did it for RDBMS testing here, that's why I use this. Anyhow, so I declare this query and then now store load query. I execute the query and I load the cursor back. Not the cursor, I beg your pardon, the result. It doesn't open any cursors. I mean, it may open it on the server for a few, microseconds, whatever, to load information, whatever you do, but it's a disconnected model. Okay, so now I have my result variable is of type is just a list. So I see that I got one result set, I get my row set, and then I what I do here, I see there is no data. Now I create my dynamic row with the schema that came from this query. You see this? I pass the schema here, and then because it's a dynamic row, I cannot use its properties. It doesn't have any properties, and I set them as fields by name, and I do, validate, and I insert this information, store insert row. I insert it. So for those of you who are familiar with like active record pattern or something like this, this is a similar concept. Okay, what's going to happen now? The provider will generate the insert statement or whatever statement is necessary. If you work with MongoDB, it will generate the document DB collection insert or whatever it's called. I don't remember. Then you load it again, and you see that this time it returned you first name, returned you Jack, because it's it was set to Jack here. All right. And in the database, the name of this column is different, remember, because we said first name is called FN or something with a field definition. And so the same thing we can do with the typed row, only here I do the same query and I give me a type of patient row. And it will return that is the same thing, only now I use properties. You see that? I use those properties here. And I can do the same thing over and over again, and then I can insert many rows, and I can insert them in the row set, and then I can save the whole row set. So the row set has property called log changes. If that's true, then whatever change you make to a row set is logged, and then you can this whole row set with one blow to the database. Okay, so I can already hear a question, that you're asking at this point. Well, why don't you use link to SQL? Why did you use that? Well, let me tell you a few things about link to SQL. Link to SQL is just a popular thing right now. There is nothing new about it. Believe me. We have worked with a concept of like link to SQL-like concepts back in the 90s. Where there was a product called Borland Delphi, and one guy created a library where you where you transform your statements from your code into something like an expression tree, and then he generated statements for Oracle dynamically at runtime. Okay, so I am intimately familiar with the concept of link to SQL-like from the 90s, and I can tell you that this is all good on paper, but it is very hard to use in practice. Because in link to SQL, you cannot really match the internal language of your database with generic relational algebra source, set of operators that Microsoft tried to do. And don't get me wrong, I'm sure that link to SQL solves 95% of the problems in 99% of the websites. But NFX is a framework for building large and complex applications. And in Oracle, for example, there are a lot of functions like windowing functions. I might have a link here on a different monitor. Yes, here is a post. SQL for analysis and reporting. So there are things like, the slag lid, functions that allow you to navigate between rows, first, last, windowing functions like with the that you can apply certain statistics like a rolling window to like salary ranges or inventory counts, etc. So in my career, I have built many applications that had to process tens of millions of rows in Oracle, and let me tell you, once I started using this features that Oracle have built for us, for developers that is, my queries, and I'm talking like 1999, the year of 2000, 2001, okay, those performance of those functions, you can calculate all of that in your code, of course, but those functions are going to give you 10 to 100 times better performance because they're natively built in the Oracle kernel of their database engine, right in their kernel of their system, not in the operating system kernel. In Oracle, that is core. That's what I'm saying. So once again, how do you do a connect by, for example, or how do you do a pivot with a rollup or something like this in link to SQL? So what I've seen people do using link to SQL and link to entities is a similar concept. What I've seen people do, they write store procedures. Excuse me, if you write a store procedure, then what does link to SQL give you then? It is just another abstraction layer, and furthermore, link to SQL or link to entities is a very hard to grasp concept when it comes to non-homogeneous or homogeneous, how they call it, stores. Like I can have some data in RDBMS, another in the document store like Cassette or MongoDB, and some other information I may store in plain text files. And I want to put a facade in before my text files that I store on the hard drive as a web service. So it's a hybrid store now. I don't have a unified API. So how does link to SQL help me? It can't. Because it's a different scope of. So what I'm saying is there is a deliberate thinking and deliberate action that we took here when we did it, because this has nothing to do with SQL altogether. This is not a SQL, but it's a hybrid system. All right, so I think this is all self-explanatory. Okay. And you understand that you can work with your relational database like this. Now the question is, how do you write your queries? There are two types of queries here. The first type is the scriptable query that you can write right here. Okay, it's just a file. You compile it. It is in an embedded resource. You compile it. The name of the query is the name of this file. So when I say in my code, where is it? CRUD patient list. What it's going to do, it's going to find CRUD folder, patient list, and since I'm connected to MySQL, it will understand this prefix and this suffix, and it will chop those two things off here, and it will load this file, and it will execute this query that I write by hand. I could have called a store procedure here. It doesn't matter. What matters is that this syntax here is the native syntax of my native database that I use. So had I been doing this for Oracle, I would have had here aura.sql, okay, because the provider searches the appropriate file by the suffix here, okay, and then what happens, I could have used a very, very complicated, mumbo jumbo join with by union all, compute by, windowing function over, common table sub expression is another pain in the butt when you deal with the link to SQL. Well, at least it was until like 2011, I think. I haven't followed link to SQL for the past few years, or link to entities for that regard. But other than that, you don't need to invent any language. You use whatever language you are used to in your particular database, and you can use whatever function natively you use in your particular database. Now the question is, how does this then work? How do I get my data? Very simple. There is something called a pragma here. What this guy does, it allows me, it supplants this information that I have in my regular query with some metadata that tells me that can make actually this, it can make it writable. So I can say what fields I want to I can join tables here, and I can say that some fields are not are not necessary, okay, or are necessary to load, but I don't want to store them. So this is extremely powerful, and what is more powerful is that you can put description of the fields here, and then once you connect to that UI interface, to that query result, you instantaneously give that all of the keys and everything, all of the captions and all of that stuff, whether it's a read-only field or can you change it in the edit mode, in the insert mode, that's a key field. Can I change it? Can I enter it by hand or not? So here, the modify pragma tells me the target table name that is going to be modified. If I don't include this pragma here, this query is not gonna give me a modifiable result. I cannot save this query back to the database. You know what I'm saying? Because, I mean, what table do you write into? Patient, doctor, or doctor? There is one patient table and two joins on the doctor table here, or one join rather. Because what I'm doing here, I'm showing some information about the doctor. I'm showing doctor phone and doctor ID. See this? Those two columns here, they're not a part of the schema. This is a very touchy subject, always, dealing with the foreign keys in the relational database schemas. So, back in the 90s, I had to work in the system where we had to do like tens or hundreds of tables. They're complicated, large tables, and a lot of fields in them. And of course, we could not allow to create a user interface for every table because it would have taken us 25 years to finish that system. So instead of we did like a scaffolding framework, what they call now scaffolding. Back then we called templatizer or something. And it used those concepts so where you can supplant your query with some meta information, and it will use that to make your life easier. So, but let's say that this query is written for Oracle, and as you know, Oracle is an extremely powerful database. But let's say I need to write a query for MySQL. And MySQL SQL doesn't have those capabilities. It doesn't have those crazy windowing, statistical windowing functions, for example. And in my SQL counterpart, I need to execute 3 queries instead of 1. How do I do it? I can easily do that. I can create a query handler, and I can register it with the system. And I can do another problem here with link to SQL is that it's very hard to do dynamic queries. So what are dynamic queries? The dynamic queries are the ones that the user creates. They are mostly used for reports. Okay, so let's say the user have a flexibility to select a complex filter and indexing and all of that, filter and sorting and everything, and you need to output a report. So usually you create a series of store procedures or series of dynamic SQL statements that are drastically different depending on the user interface form filter selection. Okay, how does one build similar functionality with expression trees? Well, you could do that. You could build those expression trees, but it is just not practical. It's very hard. It's a lot of code you need to write and everything. It's much easier to write a conditional SQL statement. And of course, many of you are already scratching your heads and asking me, this is not secure SQL injection. Well, you have to understand what you're doing, okay? The SQL injection is a problem. It doesn't go away. It exists. It has always existed and will exist forever. You need to understand what you do. You need to never concatenate strings. You need to scan your input, and you need to understand what kind of commands, how you build your commands, etc. With the link to SQL, the people say if you use link to SQL, you are not prone to SQL injection. Of course you are. There is second-degree SQL injection, and there are a lot of stuff. There are, websites that talk about it. So no matter what technology you use, you need to understand what you do. But the last thing I'm going to show you is this. This is a business system, okay, that uses this concept here. But what I want to say is that here is my provider for my SQL, okay, and I'm completely database agnostic here, so I don't have to use MySQL, but I use MySQL for this system for today. And here is the list of my SQL statements. Most of the SQL statements are just what they are. Okay, they are automatically generated inserts, CRUDs. You don't have to generate, but some of them, some of them are have some business logic, so I felt more comfortable putting them as a script right here. Okay, so I can call them from my code. And then there is a complex SQL here, complex query rather, called user list. So the user list takes a lot of parameters. It's a report, so to speak. It's a complicated grid, complex grid that has many parameters. So here, a lot of SQLs are built, dynamically, whether I want to include those columns and I do not want to include those columns, and I blah, 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 blah. So what happens here is that the user list filter is a form that is that is fed into the query, and if you look here, it is a form. A form is just a subtype of a row. So once I communicate my client environment with this form, I get all of those fields in my client, on my GUI, that is. On my website, I get all of those fields, and they're all glued to the server automatically. So when the user types something banned, for example, he clicks on the button, hint banned accounts. Okay, so that's the tooltip that the user sees when he moves the mouse over that field. Okay, description, last login, placeholder, last login date, span hint, last login date, span from to, both optional. So you can put, in the syntax like this, you can put it as a string. So once you do that, the form gets saved, the filter form gets saved into the query. Look at this. R7 app, data load, one row set, grid source admin, user list, query params, filter this. I pass myself as a parameter for the query, and then what happens, I get here, and this is all in a different assembly. So if I want to re-implement this in Oracle or Cassandra or HBase, I will definitely have an ability to do that. I will not have an ability to use SQL in Mongo, but I can use some other options that MongoDB gives me. Right? So, but because I'm in the MySQL namespace, I'm going to do this, and I'm going to build a pretty tricky SQL. Well, I mean, it's not tricky, it's primitive actually, but it has a lot of, here, filter band, the band date is not null, for example. That's a condition that I add, and then you have to understand what you do definitely. But this is, I mean, you can build something like this. If you think about it, how much stuff you can accomplish with this. You can build a screen, a compact screen with many filter parameters. I think it took me like 45 minutes to put this all together from scratch, including the form, including this form with all of the fields, and including all of the backend logic, and including this. And that shows you a beautiful grid with syntax highlighting, with a list of users, when they have registered, when they have visited the system, all of that stuff. A lot of code. So, but the point here is that the query is implemented as a class, because that's not a single SQL that I can send. It's a dynamic SQL statement. That's just my implementation technique that I have selected in this particular project. I'm not telling you that once you use NFX, that's how you need to work with the SQL. Absolutely not. You don't have to combine or concatenate SQL strings like I do here. Okay? So if you're familiar, like if you're used to using store procedures, you can use store procedures here, whatever you want. It's just the flow of events and the architecture gives you the way to write a query either natively as a SQL statement or create a custom handler. And all I had to do here is this. Just create this class, implement this interface, implement this, derived from this class. It has some business logic here for this particular R7 query handler. It's just a CRUD query handler, and what it says here is just a base class. That's it. It's just a base class, and you write it once, and here you go, and it does all of the stuff for you. So, to summarize, NFX does not use ORM. We do not create objects just to map to entities in the database. We use hybrid objects that are usually projections of 3 to 4 tables from your RDBMS system in our code. We create objects that we need for the code, not the objects that are needed for the database. Okay, so that's how we handle the impedance mismatch, how they call it. And we do not use link to SQL, and we do not use link to entities or any other Hibernate or any other technology. Everything you have to use for the interfacing with the database is right here, and then the actual provider that does that, they're right here. I support MySQL, Microsoft SQL, and MongoDB for today. Okay, and that covers the whole spectrum in NFX, and you can create a provider for your own system. You can create a hybrid provider for the hybrid system that has some data in Oracle, some data in this, some data in that. And the most important thing here is that this stuff is all in one assembly here, so you don't need any third parties. And one last thing, the unique sequence provider, this has a concept of unique sequence generation. If you're familiar with Twitter, Snowflake, and projects like this has a concept built into the NFX for the generation of unique IDs. It relies on the identifier called DID, Global Distributed ID. Okay, so that would allow you to address 2 to the 96 power combinations. Okay, and the providers know how to store this stuff efficiently in the databases. And what this is used for, this is used in the distributed environment where you may have thousands of nodes and you need to generate distributed IDs. But that's the whole different conversation here. The only thing I'm going to mention here is that the CRUD concept was built with the distributed systems in mind. So therefore, if you come just from the local database perspective, you have a local SQL server or under your desk, or the SQL server that serves 10 users on the floor, or maybe 15 users or whatever, then you're not gonna understand what this stuff does and why it was built this way. Okay, if you have a data store where you need to store 25 billion rows every month, and or you need to store a lot of like high frequency trading bets or something like this, a lot of data is coming to your application and you need to do tens of thousands of insert every second into Mongo or Mnesia, in Erlang or MongoDB, then you would definitely appreciate the core of the system, the way how we built it. You could really utilize it and benefit from it a lot. Okay, and one last thing here, there is an interface here for the distributed data store, and I encourage you to read this out here. But this is a monster Twitter/Facebook system for organizing huge data stores. I'm talking exabytes of information here. The data stores that are segregated in banks, schemas, areas, and they have the concept of replication and versioning, and NFX does not provide the product that implements those interfaces. They're just laid here as a groundwork, like a wireframe, so to speak, for the technology. We have a different framework called ALM cluster that is built for that, and it has a database, a distributed database that can handle billions of rows. But the way how you work with data in systems of this scale is very different from your typical RDBMS thing. So keep in mind, when you look at those interfaces in CRUD, you can use CRUD to work with local database, but most of the time you would benefit from working with the non-homogeneous distributed systems where data comes from different technologies and different even places. Okay, so and more information is available here in the manual unit test in the N unit, not the manual, in the N unit data access. There are a lot of unit tests here for dynamic rows, for the Rosettes. You can see different use cases, how you use different Rosettes. And again, this is not test-driven development. This is testing real patterns written by a human being, by different actually developers who use this. Okay, so this is not like this doesn't test. If this returns true, then this returns true. False otherwise. I don't believe in documentation like this. I don't believe in the bullshit tests that test nothing. Okay, those tests, they are designed. Those tests, they're software of its own kind. So if you read those tests through, you will get a lot of use patterns of how to do different things. Test objects. Here's a good example of targeted fields and all of that. And unit tests cover all of those use cases and edge cases. Okay. So there are a few hundred unit tests just to cover this stuff here. And another part, there is an integration test that connects to real SQL database, and you can, not this one, but you can create a local schema and run this script here, create tables, and it creates this 3 tables or 2 tables, doctor, patient, and types, and then it cross joins some of those tables, populates them, and those unit tests there, working with this integration tests, and we use NUnit for integration tests. Is this the right thing to do? Probably not. But for the lack of better technology right now, and don't tell me about MS test. I used a MS test. I'm not impressed at all. We are going to create a special framework for unit testing and integration testing in future, because it has to be integrated in NFX, because it would understand a lot of things like application container and configuration. So I wouldn't need to repeat all of that bloat 25 times, because then NUnit has no concept of application container, for example, and I need to set it up where I need it in every unit test. But there are other things, so let's not get into this, but you can get a lot of insight on how this works from those unit tests that are right here. So everything is in NFX solution, and that should conclude it for today. Thank you for watching.